Hello everyone. Today I'm going to talk about the demilitarized zone, which is a feature used in network security to protect internal networks from outside. So I'm using Packet Tracer. This is a Cisco Packet Tracer, a simulation tool provided for Cisco Academy for allowing their students to simulate Cisco routers and switch, learn how to configure these devices. So I'm going to use this tool in order to simulate a DMZ or demilitarized zone. First, I'm going to divide this recording into three parts. The first part, I'm going to explain the setup of my network, or let's say the design of the network. The second part, I will talk about routing, and the third part, I will talk about access list, configuration of security, and all the necessary features. So first, let me just start describing the network that I have at hand. This network is made of three parts. So the first part is what we call internal network. My internal network contains two different segments. Segment 172.16.0.0/24. Of course, you recognize this is a class B network subnetted. And the second segment 172.17.0.0/24. So I have two different segments that make up my internal networks. Now these two segments will be able to communicate with outside, or let's say with outside network through a service provider that I'm simulating here, through a region here, through a segment that I call demilitarized zone, or DMZ. Why do we need to use DMZs? Generally, we have servers that provide some services like web servers, like FTP servers. Now, we want to provide access to these services for users from outside. Now, if we keep the services or the servers inside the network, our internal network, and we allow people from outside to have access directly to them, this will create holes and breaches, and this might create a lot of vulnerabilities on the internal network, and this might lead hackers to access internal assets and platforms and do whatever they like to do. In order not to allow anyone from outside to have a direct access to internal network, what we do generally, we migrate the servers that are provided to outside users into a segment that we call a DMZ, demilitarized zone. So like this, these servers will be accessed from internal network users, and at the same time they can be accessed from outside network users. So those outside users will have a direct access to web server, they will have a direct access to FTP server, but they will be blocked for internal network servers. Of course, here we might assume we have internal network servers like database servers, and any type of servers that are needed by any corporation, any organization, and we want to not allow anyone from outside to have a direct or easy access to them from outside. Why I'm using the words easy? Because in the world of network security, said nothing is impossible, but network security is just making things harder and difficult. That's all. So in this video, I'm explaining the following. I'll explain the following. Users on this network, on this segment, 172.16.0.0 should be able to communicate with users on this segment, 172.17.0.0, and the same is true. Now, unless you want to provide some filtering and access lists that allow specific hosts to access specific hosts on the other segment, and deny one host on this segment to access another host on this segment, of course you can do this kind of filtering. You can go to a certain extent, very deep if you want, but in our case, in this demo, we don't do that. I'm just simulating one network here, another network here, and provide full access between the two segments. Of course, this access will be done through this router. So this interface of router will be the default gateway for this segment, and this interface of this router will be the default gateway for this segment. Now, any user on the internal network should be able to access the web server using HTTP protocol, or HTTP as the secure HTTP. Same thing for the second segment. Any user from here should be able to access the web server or the secure HTTP server if he wants security to be available on his web transaction. Same thing, any user on both of the two segments should be able to access the FTP server that I'm simulating here to download some files or to upload files, whatever he wants. But look also, at the same time, these two servers should be accessed from from outside. So any user who is connected to this ISP from outside cloud should have access to web server and to secure web server, and as well as to the FTP server. So of course we don't want these two servers to be put on the internal side here. That's why we migrate them to this segment. Now this segment is our DMZ. Not only that, if any one of these users want to access any one of these servers, there is a direct path to that machine. Now, if any one of these users is not interested to access FTP server or web server, but just want to access outside networks, so all his packet will be forwarded through this link. You know, there is a direct link between the inside router and the outside router. And then the packet will go outside, and of course reply will be received also from outside. Now going further here, we have two routers that are defining our perimeters. The inside router, this inside router will block all communication from outside to inside network. We have the outside router. Outside router actually is the router which is used to connect to the outside world, to the outside network, or to the cloud, internet cloud, or any outside network to be accessed from internal users. So this is the description of the design of my network. So this is all for this first part. See you in the second part. Thank you. This is Hakim Adish. Bye.